In this video, we'll do a prep for the graphs of exponential functions by doing a quick review of the transformations of functions. And we're actually going to do this by looking at some of the transformations on an actual exponential function. So a little preview of what you're going to see. So let's say if we have the function f of x equals to 2 to the x. So you see that as you go to the right, the function is increasing, and as you go to the left, the function is decreasing and getting closer and closer to the x-axis. Now, if you remember when we were talking about vertical shifts, then what you would do to the function is, let's say if I wanted to shift the graph up 5 units, I would add 5 to the entire function, and it shifts the graph up 5. Or if I wanted to shift the graph down 3 units, say I subtract 3 from the function. Now let's say if we wanted to do a horizontal shift. Now if you remember, if we wanted to shift it to the right 5 units, then you subtract 5 from just the x's. So in this case that would be 2 to the x, the 2 to the quantity x minus 5, and that shifted the graph to the right 5 units. And if we wanted to shift it to the left, let's say 2 units, add 2 to just the x's, and it shifts it to the left 2 units. Now let's say, what if we wanted to do a reflection about the x-axis? Now remember, to do that, you put a negative in front of the entire function. So what that did is it reflected the graph about the x-axis by having a negative 2 to the x. And then if we had wanted to do a reflection about the y-axis, you put a negative in front of just the x's. So you see that we now have reflected the graph about the y-axis. And then there were the vertical compressions or stretches. So to do that, let's say if we wanted to do a vertical stretch, what we do is multiply the entire function by a number greater than 1. Let's say if we want to do it by a factor of 3. So I multiply the entire function by 3. Oops. What it did is it stretched it about the x-axis by a factor of 3. So like for example, the point, we originally had the point 0, 1, now it's up to 0, 3. And at let's say 1, 2, that's now at the point 1, 6. Now if we wanted to do a vertical compression, we'd multiply the entire function by a number between 0 and 1, but not including 0 and 1. So let's say 1/2. So what that did is it compressed the graph about the x-axis. So again, let's say originally we had the point 0, 1, now it's at 0, 1/2. Now if we wanted to do a horizontal shift or compression, let's say, or not shift, sorry, a horizontal stretch or compression. Let's say if I wanted to stretch the function about the y-axis by a factor of 2, then what you do is you multiply just the x's by 1 over 2, so 1/2. So what we did was we stretched the graph about the y-axis by a factor of 2 in that case. So like for example, we originally had the point, let's say 1, 2, now it's at, sorry, 2, 2, sorry, it was at 1, 2, now it's at 2, 2. Okay. And then if we wanted to do a horizontal compression, then you multiply the x values, let's say if a horizontal compression by a factor of 3, we are 1/3, we'd multiply it by 3, and just the x's, so that'd be 2 to the 3x. So that's what it would look like with the horizontal compression. So doing the transformations on functions, even if they're exponential functions, are still the same. And as you'll see when we talk about logarithmic functions, again, those transformations will also be the same.